All right, let's do L'Hopital's rule. L'Hopital is the name of a dude that you are going to like very, very much. So here's the deal. We've talked about the indeterminate form, 0 over 0, and really infinity over infinity is also indeterminate. Now, I'm going to be honest, all of these other indeterminate forms are ones that we will not discuss in AB. BC does other indeterminate forms, but those are also, just want you to be aware of the other indeterminate forms that are out there. And then I put some determinate forms, infinity, negative infinity, minus infinity, infinity plus, 0 to infinity. But here's the deal. Our class is really limited to these two. In the scope of what we are doing, we're only going to be looking at those two. So remember way back in September, or probably August actually, we did limits, and we're kind of, again, I'm just kind of throwing this in here into this unit so you have it before the semester exam. And of course you'll use on the AP. But with this limit, remember you always did direct sub first, and so when I did direct sub, you plugged in 2 and got 0 over 0. You thought, oh, I got to do something with it. See how much of this you remember. So you said, okay, I'm going to factor. So you would factor that. Hopefully you remember how to factor that. The x minus 2's cancel. And then you were able to do direct sub. So you plug in that 2. So that would be what? 2 squared, that would be 4 plus 4 plus 4. So you would get 12. And those algebraic steps are wonderful and great and fabulous. But is there a mathematical way of doing that maybe a little faster? And the good news is, yeah, there is, thanks to L'Hopital. And so here's what he determined. If you have the limit of a fraction and you get the indeterminate form 0 over 0 or infinity over infinity, then you can use L'Hopital's rule. And his rule says that what I can do is I'm going to take the derivative, the limit of the top, the derivative of the top and the bottom. I'm still singing the song. If you missed it today in class, sorry, you missed a show. But you take the rate of change of the top and of the bottom. And so that's what you're going to have to find. So let me show you how this kind of works. Now, I still do direct sub. I still would plug in the 2 and get 0 over 0 because I have to know, again, L'Hopital's rule, it doesn't work for every fraction. It only works when direct sub gives you 0 over 0 or infinity. So I still have to do the direct sub part. But when I do, I can then say, let me take the limit, let me take the derivative of the top, just the top. I'm not doing quotient rule, I'm just looking at this. That gives me 3x squared. The bottom gives me 1. When I plug in 2 there, well, if I plug in 2, 2 squared is 4, 4 to 12, man, I'm there a heck of a lot faster than doing all the other algebraic steps. And I know what you're thinking. You're like, why didn't we do this at the beginning? Well, sweet friends, at the beginning, you didn't know what a derivative was. So I couldn't have done this at the beginning of school. So you are now able to use this when you get 0 over 0 or infinity over infinity. If you did not get one of those, do not use L'Hopital's because it's not going to give you the right thing. So let's try a couple. And we're going to talk in a minute if this were on free response. So I am going to pretend that all of this is on multiple choice. So there is a certain way you have to write it on free response that I'm going to talk about. But so I'm going to pretend 1 through 5 here is on multiple choice. That means your notation doesn't have to be as great, but I am going to have good notation anyway because it's just my habit. But here's the deal. Let's go. Direct sub. Plug in the 4. 4 plus 5, 9. 3 over 3, that's 0. and 4, 0. I will say, remember, you never want to do that. You never want to set a limit equal to, do not write equals to the indeterminate form, if you remember that from the beginning of school. So let me now take the derivative. Since I'm able to use L'Hopital's rule, I'm going to say the limit as x approaches 4. Now think of this one as being x plus 5 to the 1/2, okay? So I'm just going to kind of, again, this is on multiple choice, so I can kind of write whatever I want. So I'm going to think of that like that. I'm going to think of that numerator that way. So power to the front, decrease the power by 1 would be x plus 5, so I'll just put it down here, to the 1/2. Okay, so that's that, the derivative of the top, over 1. Well, the over 1's not too bad. Now let's plug in the 4. So I really have 1 over 2 square root of 4 plus 9, and I would get, ding, 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 1/6. So that is my limit of example 1. So what I want you to do is see if you can do example 2. All right, here we go. Direct sub, plug in 0, cosine of 0 is 1, 0, plug in 0, 0. Okay, so what is my how am I going to use L'Hopital's? Again, on that bottom, I'm going to think of that as sine of x squared. So let's see how I would use L'Hopital's rule. I have the limit as x goes to 0. The derivative of cosine is negative sine. The derivative of 1 is, of course, 0. The denominator, power to the front, decrease the power by 1, multiply by the inner derivative, and I would get that. Now, of course, I'm going to be smart about it. Can you cancel that? Well, absolutely. So I really have just the limit as x goes to 0 of negative 1 over 2 cosine of x. When I plug in 0 here, of course, cosine of 0 is 1, and I get negative 1/2 as my answer. Don't you love L'Hopital's rule? Now, again, with the infinity ones, honestly, being that we did those so fast before, I just use in behavior rules. So I certainly am not trying to change that because, frankly, that's so fast anyway. I'm hoping you remember when x goes to infinity, all you have to think of is EBA rules. But if you didn't, I just want to show you that L'Hopital's does work for these. And it brings the point that sometimes you have to do it twice. And that's true when you get 0 over 0 as well. But when you plug in infinity, well, you have infinity squared. Well, that's a really big number. And on bottom, you have a really big number. So the direct sub gives you infinity over infinity. Well, if I take L'Hopital's rule, the derivative of the top would be 6x. The derivative of the bottom would be 4x plus 1. Now, when I plug in infinity, well, I'm still getting infinity over infinity. So I can do L'Hopital's rule again. Sometimes you have to do it twice. And then, of course, you're down to a constant, and the derivative of any constant is that constant, so I get 3/2. All right, you try the last two. See if you can do those last two examples. So stop the video and try. All right. Example 4. Oh, I hope I didn't catch you. I hope you didn't get lazy and just go, oh, I'm going to do L'Hopital's because it's a fraction. When I do direct sub, 1 plus 1 over 5 plus 3, I get 2 over 8. I get 1/4. That problem can't use L'Hopital's. Think about it. If I did, my derivative would be 1 over 5, and I would get 1/5. So that's the whole point of you don't use L'Hopital's just because you see a fraction. You use L'Hopital's when you do direct sub and get 0 over 0. All right, last one. This one does give you 0 over 0. So let's do my derivative. Hopefully you remember the chain rule. The derivative of sine of 4x is cosine of 4x times 4 over 5. And then when I plug in 0, of course, the cosine of 0 is 1. So I have 4 times 1 over 5, and I get this. Okay, if you have not paid attention, which you would never do that, but man, put a star, cloud, whatever, because L'Hopital has shown up on free responses of late, and they are so picky on how you have to write your answers. So I'm pretending that this is on free response. Now, generally they're a little harder than this one, but the notation is the same. So here's how you need to write it if it is on free response. First of all, again, don't you dare do this. If you write that, they literally stop looking at your paper. However much it's worth, you didn't earn any of the points, they do not look. Don't ever write a limit equaling to the indeterminate form. Now, do I out to the side do direct sub? Yes. Or do it in my head? Yes. I can even write it out to the side. Fine. When I plug in 3, yes. Do I get 0 over 0? Absolutely. But you have to write why you are able to use L'Hopital's, and this is how they want it. Since the limit as x goes to 3 of x squared minus 9 equals 0, and the limit as x goes to 3 of x to the 4th minus 81 equals 0, you have just proven that you got 0 over 0, but you have to say it. And you can't say, by direct sub, I get 0 over 0. They want you to use calculus words, limits, so that's what they want you to say. It's just the way it is. So since those two limits equal 0, and then say by L'Hopital's. By L'Hopital's, what? The limit as x goes to 3 of, now take the derivatives, 2x over 4x cubed equals what? Plug in your 3. 3 times 2 is 6. And plug in 3, that's 27 times 4, 108. And of course you can leave it that way. You don't have to reduce, but that is 1 over 18. So the limit of this thing equals 1 over 18. But what I wanted you to see is that notation right here, because that is super, super important. You have to write it just like that. You guys, it's a game. I'm teaching you how to play the game, and you got to play it. If you want the points, you got to play it. So get that in your head of how you have to write L'Hopital's on free response. Now, I don't expect you to do that on your homework. I was very on every single problem, or you'd take forever. So there's only the very last problem I said use correct free response notation. So you can practice it once, but I don't expect you to do that on every problem of your homework. So you can go the fast way for the other ones. All right. Good job, everybody. See ya. Whoa.